Hello. So I wanted to do a video just kind of going over these extra solving systems practice problems in anticipation of your quiz or test that's coming up in just a couple of days. So use this video however you want. You can go through each one with me. You can kind of skip around and see when I'm working on different problems. And hopefully it's helpful. So let's start with number 4 or number 1. Looking at this one, I know, oops, so so large. I know that I'm going to be using elimination. And the reason that I know that I'm going to be using elimination is because it's not in an easy peasy form of y equals mx plus b. So I can't just plug something in. Instead, I'm going to be eliminating something. I'm not substituting, I'm eliminating. Looking at this, what do I want to eliminate? Well, I could choose to eliminate my negative 10, or I could choose to eliminate my negative 15y. In this case, I think I'm going to go with smaller numbers. So I will go ahead and delete my 15y. And let's take a look at what that does. So in order to eliminate, you have to multiply one of the problems by any number that you come up with. In this case, I know that I'm going to be getting rid of my negative 15y. So I'm actually going to multiply this bottom equation, the full equation, by negative, negative 5. No, I'm sorry, negative 3. And watch what happens when I do that. So I have to distribute. So negative 3 times x is negative 3x. Negative 3 times negative 5 is positive 15y. And then negative 9 times negative 3 is positive 27. I need to make this a little bigger. Positive 27. Okay, so now do you see what I did here? So I can actually take this out because this down here is my new equation that I'm going to be working with. And now I just need to add these two equations together. I'll start on the left side. So negative 10x plus negative 3x is going to be negative 13x. Negative 15y plus 15y is 0. So that's where our elimination is coming into play, is that I now have a negative and a positive. They can get out of here. So I ignore my y's, which are now zeros. So negative 13x equals 27 plus 25. Got to get out my calculator. Is 52. 52. And then divide by negative 13 on both sides. Divide by negative 13. And the answer is x equals negative 4. So great. I now have my x, but I still need my y value. So I'm going to go back into one of my original equations. I'll erase some of this. Into one of my original equations and just plug in negative 4 for x. So I'm going to choose this second one because it looks a little bit easier, but you could choose the other one if you wanted. I'm just going to rewrite this. So now instead of x, I'm putting negative 4 there, minus 5y equals negative 9. And then I solve. So add 4 on both sides. I have negative 5y equals 98765 equals negative 5. Divide by negative 5 on both sides. Divide by negative 5. And you get y equals 1. Ooh, had to sneeze. Y equals 1. And then you just have to write it as an ordered pair. So in this case, you're going to do negative 4, comma, 1. Great. So that was our example of elimination. Elimination. I'll just do it elimination. So let's try something else this time. And when I worked on this problem before, this number 5, I tried to do substitution because I had my y values and it was in y equals mx plus b and everything was feeling hunky dory. But I ran into a big issue with this fraction. So, what I should have done and what I'm going to do now is I'm actually going to graph this problem. So, I'll just write graph on top of here because that's just going to be a lot easier for me. And if you're going through a problem and you chose substitution and you're getting some wonky answers, try graphing it. Try and see if that helps or works out a little bit better. And sometimes it does. In this case, it did. So in order to graph, again, I have my y equals mx plus b, where my m is my slope. It looks like little mountains or hills. And then the b is my y-intercept, whether you believe it or not. Funny joke. Okay, so I'm going to graph my top one first. Always start with my y-intercept or my b. So I go up to 3 on the y-axis. Boop. And then I have a slope of negative 1 over 3. So remember, slope is also rise over run. So I'm going to actually go down 1 and then to the right 3. 1, 2, 3. Down 1 to the right 3. 1, 2, 3. And I'll do that in the opposite way. So up 1 and to the left 3. 1, 2, 3. Up 1 to the left 3. Great. And then I just have to do my second one. In this case, negative 2 is my y-intercept. So I go to the y-axis, go down to 2, put a little dot there. And then my slope is negative 2, or if you remember from so long ago, 2 over 1. Because any number could be made a fraction if you just divide it by 1. All right, so my negative 2 over 1, so this time I go down 2, and then over 1 to the right, down 2 over 1 to the right, then you go in the opposite direction. Up 2, over 1, up 2, over 1, up 2, over 1, and I can stop there because we have our answer. If you have trouble figuring out what the cross sections are, you can always draw lines from the 2. And in this case, it's going to be negative 3, comma, 4. And that's what you would just write here in parentheses as an ordered pair. Negative 3, comma, 4. And voila. Okay, so let's try. We have elimination. We have graphing. So let's try doing a substitution this time. So I'm going to go down here. I know that this one is actually going to be substitution. All right, substitution, Great. And then with substitution, much like elimination, where we are working to eliminate or get rid of one of the variables, in this one we're substituting something in for one of the variables. So pay attention. If you get confused, pay attention to what the name is actually telling you. So here in substitution, we're going to be substituting. Thank you. And we know 2 pieces of information. We know that y is equal to negative 3x plus 20, and y is also equal to 4x minus 15. And if you think about that, if I have 2 things that are equal to each other, I have y equals y. That makes sense. 1 equals 1, 2 equals 2. Well, in this case, if I know 2 things that y is equal to, I can actually just set them equal to each other. So in this case, I'm going to do negative 3x plus 20 equals 4x minus 15. And this would work too if I had a problem where only one of these was in the y equals mx plus b form. Just anywhere that you saw a y, you would plug in whatever y was equal to. So 4x minus 15 or whatever it may be. So just keep that in mind. You're doing the same thing that you were doing up here where you had an x and you substituted negative 4 in for x. You're just doing the same thing. It's just a larger chunk. But in this case, we can just make them equal to each other. And then you solve. So I'm going to first subtract 20 from each side to get rid of my 20. So now I have negative 3x equals 4x plus 5, because negative 15, oh, nope, negative 15 minus 20 is going to be negative 35. Okay, and then I can get rid of my 4x by just subtracting 4x on both sides. So negative 3x minus 4x is going to be 3, 4, 5, 7. Negative 7x equals negative 35. Divide by negative 7 on both sides, so that x is by itself. Divide by negative 7. And then x is equal to positive 5, because 7 goes into 35 5 times. Okay, and then I just go back to one of my original equations and now plug in 5 for every x that I see. I'm just going to choose that second one, and I can now write, I'll change colors. I can now write y equals 4 times x, or 5 now, minus 15. And then you just solve. So order of operations, 4 times 5 is 20, minus 15. 20 minus 15 is 5. So y equals 5. And in this case, they both equal the same thing. Write it as an ordered pair. Your final answer is just 5, comma, 5 in parentheses. All right. Well, I hope that was helpful. We did substitution, we did elimination, and we did graphing. So those are going to be our 3 big methods of solving systems that we're going to be working with on the test. Reach out to me if you have any questions, or if you need me to do like more videos. Just let me know. You guys have got this, and I will talk to you soon.